In this example, we're going to consider modular exponentiation, where our exponent is not a binary value. So 68 is close to a binary value of 64, but once we get to 11 to the 64th mod 7, the next value will be 11 to the 128th mod 7. So how do we get 4 units away, or 4 units above, where our nearest binary exponent is? So what I'll start off by doing first of all is relating the fact that we have our binary values would go 1, 2, 4, 8, 16, 32, and 64. Now, I could go up to 128, but that's too large, so we're going to stop at 64. Now, 11 to the 68th could be written as a product of values. It could be written as 11 to the 64th. So now if I take 68 and I subtract off 64, I see that my remainder is shy by a value of 4. But I also see that 4 is one of those binary values, and therefore I'm going to go ahead and highlight that, because once I subtract away 4 again, I do in fact get 0. So I'm going to have to take this 11 to the 68th mod 7 and split it up into 2 factors, 11 to the 64th times 11 to the 4th mod 7. In some cases, it may take 3 factors or 4 factors, and that's typically something we then leave up to a computer to figure out. So you can kind of see how this algorithm works. First of all, lay out the binary values that are stopping where the binary value that you reach is just less than the exponent that you have, but where doubling it again would exceed the exponent that you have. In our case, we have 68, which falls right here, and 128 is simply too large. So the next step is to work our way up to 11 to the 64th. The beauty of this is that all of the other factors that we might have, in this case 11 to the 4th, that binary exponent, that's already calculated along the way. So we're going to have to come back and split this up into 2 remainders. We're going to have remainder A, which we'll just say is 11 to the 64th mod 7, remainder B, which is going to be 11 to the 4th mod 7, and then potentially we might have to take one more step and figure out what that results in. So 11 to the 64th mod 7, here we go. We'll start off with 11 to the 1st mod 7, which is congruent to, well, 11 divided by 7 leaves a remainder of 4. And now we can work our way up to 11 squared mod 7, which is congruent to 11 to the 1st times 11 to the 1st mod 7, which is congruent to 4 times 4 mod 7, which comes out to 2. And we'll double that again. 11 to the 4th mod 7 is congruent to 11 squared times 11 squared mod 7, which is congruent to the remainder of 11 squared mod 7, which is 2 times 2 mod 7. And that's 4 mod 7, and 4 mod 7 leaves a remainder of 3. Excuse me, a remainder of 4. Because 4 divided by 7 is 0, remainder 4. And now we'll proceed. We'll take 11 to the 8th mod 7, which is congruent to 11 to the 4th times 11 to the 4th mod 7. And 11 to the 4th mod 7 is 4, so we get 4 times 4 mod 7. And that's 16 divided by 7 leaves a remainder of 2. All right, we keep going. 11 to the 16th mod 7, which is congruent to 11 to the 8th times 11 to the 8th mod 7, which is congruent to the remainder of 11 to the 8th mod 7, which is 2, so 2 times 2 mod 7. And this may look familiar in terms of our last example because of the fact that we're using mod 7. And so this is 4, and 4 mod 7 is 4. Okay, almost there. 2 more steps. 11 to the 32nd mod 7 is congruent to 11 to the 16th times 11 to the 16th mod 7, which is congruent to 4 times 4 mod 7, which is congruent to 2. And finally, as you might imagine, this is going to result in a remainder of, well, let's see, 11 to the 64th mod 7. Let's see if it comes out to 4. 11 to the 32nd times 11 to the 32nd mod 7, which comes out to 2 times 2 mod 7, which indeed leaves us with the remainder of 4. Okay, so we said that the pieces we needed to collect are to the 4th power and to the 64th power, and we have that here, and we have that here. So in our final step, which I'll just go ahead and write right above here, we know that 11 to the 64th mod 7 gives us a remainder of 4. 11 to the 4th mod 7 gives us a remainder of 4. And 4 times 4 mod 7, which is 16 mod 7, gives us a remainder of 2. And there's our final answer right there. So in essence, the process is exactly the same, but it's important to first start off figuring out how you're going to factor your base to the exponent in such a way so that you're utilizing all of the binary exponents.